So our group is Pipe AR, and our goal is to help make cities smarter by enabling us to reduce waste and to be able to better go about solving the sorts of problems that cities need to solve. I'm Akaya Tolis.
I'm Giselle.
Christian Fisher.
Caleb Graham.
Anthony George.
I'm Ibrahim.
And our goal is to help construction companies better able to manage what's underneath the ground. So if we go to the next. So if you listen to our pitch, it's when you hit a gas line or a water main line pipe, it can cost your construction company and your city money. It can hold up construction, it wastes water and time, workers get injured, and traffic gets delayed. This is a pretty big deal. Our solution to help avoid these things is to make understanding and avoiding underground objects intuitive. We're using augmented reality to overlay a map of the pipes and lines underneath the construction site to make it very easy to understand where not to dig. Pipe AR will lead us to a smarter future by reducing rerouted traffic caused by pipeline errors, eliminating water and fuel waste, and most importantly, increasing the safety of construction workers.
Yes, so we see an opportunity to implement a more intelligent and efficient underground mapping. So by translating and transcribing two-dimensional data into a visually appealing and more user-friendly three-dimensional format, an effort of development and information technology. So our innovative technology is able to increase efficiency and decrease human error and cost in the construction industry. So this transition of mixed augmented reality is building a smarter tomorrow through the process of GIS mapping, which is geographically information system, by enhancing the original data that we do have. So as you can see here, this is a 2D map that is used today. It's difficult to read, it's not fun to look at, and also it takes about 4 employees to actually go out onto a lot and to mark and survey where these pipelines are using spray paint and flags. So about 55% of the 135,000 miles of water, oil, and gas pipelines were actually installed in the U.S. in 1969 or before that, according to government data. So more than likely using maps like this, so this is obviously a very old system. On a much larger scale, it takes about 48 hours is the approximate time needed for these workers to be able to map out these pipelines. And it has to be very strategically planned because one mistake can cause a pipeline to be hit, thousands of dollars, and it can be a time delay on a project.
So it took us several iterations and several ideas before we came to our solution. For a long period of time, we actually considered doing something similar, but without the ground-penetrating radar. We also considered taking the 2D maps and being able to scan them and automatically create the 3D AR pipe system. However, this was deemed overly complicated and obsolete once the maps either are out of date or no longer used. As you can see, we brainstormed through about a dozen other ideas, but again, many were deemed to be overly complicated, out of scope, or obsolete too soon.
So instead, we chose to use ground-penetrating radar, which is already in use in the field pretty commonly, specifically in construction. And we decided to take the data from that and then be able to display that in a 3D format. Currently, they display it in a 2-dimensional format, but we can just take that exact same data and then display it in a 3D augmented reality application. And then that application can be used on a phone, a tablet, even a headset in the future once those are more commonly in place. Allowing us to adaptively deploy our maps.
So this is the fun part, what we actually built. So we figured there were some very important technical performance requirements for it to actually be useful in the field, to actually help these people and make sure that cities were able to run more efficiently and smarter. And that it had to be cost effective so it could actually be used. It had to be a not clunky interface. You had to very clearly see what was going on. Finally, it had to be accurate, both where you are on the site and which site you're even on. So here we have a very short video, or a very short segment of a long video that shows the basic idea of the prototype. And you'll be able to actually mess around with it on a phone in a bit after this. As you can see, the pipes are all laid out underneath in a very well, a much more easy way to read than on a traditional map. If you see a pipe over there, you can walk over to it and see it. And this makes it almost impossible to dig where a pipe is, because you see you're digging at the pipe. You can't make that error.
R&D is not only feasible in terms of implementation, but also cost efficiency. Using data tech already available, i.e. a ground-piercing radar, we can take that data and instantaneously convert it to a 3D map. This information can then be reused by people marking the ground for pipes instead of having multiple groups looking for their respective pipe. As a note, this marking process can take upward of 48 hours, but with our software, the time can be reduced to just a few minutes. Generally, it would be you take the ground-piercing radar, you walk around the site, you get a 2D map, but with this, it would instantaneously convert it into a 3D map in the same amount of time. And you can also save thousands by eliminating unneeded repairs and spending less time doing the actual work because you can see what's going on. This fact is especially seen by people in the industry. I personally interviewed a person who has spent years in the water department industry, and scenarios like breaking a pipe because of miscommunications is practically a daily occurrence. These mistakes can be upward of 10 to 15,000 due to worker pay, equipment costs, and the actual excavation process, depending on the severity of the break as well. And the process to convert 2D to 3D usually requires a middleman engineer to do so, but with this, there is no real requirement for that, as like I said earlier, the process will be instantaneous. And lastly, it makes people's lives and jobs easier, which is what people, especially in the construction industry, would want.
All right, so our nearest competitor who also uses VR to map underground pipes is VGIS. However, they have and the main two differences is how they use this technology and what they do with the information they got from the technology. So VGIS has a clunky drag and drop system where you drag and drop these 3D models, and they had to have been built by an engineer off-site. Meanwhile, we are automatically creating a map with the ground-penetrating radar. VGIS also focuses exclusively on construction work, whereas we will be building a comprehensive and intuitive map of all the city's systems. Meanwhile, companies that don't use AR have to use several trained engineers to read, flag, and mark from a non-intuitive 2D map that's hard to read. In addition, their maps can get outdated, they are limited, and they are also exclusively under construction.
Our end goal is to help you, and only if you break a water pipe, it's not a big problem. But if you crack a gas pipe, it could start a fire and even cause the wildfire. And it's super costly for our environment, and we cannot afford losing more trees on our planet.
Right. And to show off the prototype,
Yes. We can actually take questions while we're doing the prototype.
All right, so here you can see this is basically.
So with the GPR, are you able to differentiate different types of pipes?
We can differentiate what the pipes are made out of, but not what's in them.
Mm-hmm.
Luckily for our purposes, there's no type of pipe that you want to hit.
Yeah.
It's just using that.
True.
Yes.
Yeah, so it just shows the pipes displayed.
So the coding that's going to transform 2D to 3D, does
Yes.
that already exist?
It
Or is
already
that something
exists.
you're going to have to code?
It already exists in some form. The radar knows how deep everything is. It's just currently its output is in a really inefficient way. So we would have to code a way to make its output better, but that's the problem we're facing, and that's what augmented reality helps us solve.
Well, the augmented reality is the way you can display that, so I can look through my phone and know there's a pipe down there.
Yes.
But I'm still wondering where the software is going to come from that would translate the 2D coming out of the ground penetrating radar into the 3D augmented reality.
So the ground penetrating radar, from what I understand, maps out pretty much in 3D. It can sense how deep anything is, and as well as being able to survey a large area. So we can pretty much already get a 3D map. It's just usually presented in a graph sense, and we're presenting it instead in AR.
Okay, thank you very much.